Hi everyone, myself Sony K. Cherian. I am a PhD scholar from IIT Hyderabad. Today I am going to explain one of my thesis work, that is sulfur confinement into highly porous banana peduncle-derived carbon for high rate performance lithium sulfur battery. My PhD thesis is focusing on the development of cathode matrix for lithium sulfur battery. This is one of the work, that is I used banana peduncle, a waste material, as the precursor for developing the carbon source, and I used that carbon matrix for the sulfur incorporation and used as cathode in lithium sulfur battery. So, before going into the detail of my paper, first we must know what is lithium sulfur battery. Like any other battery system, this battery also have an anode, cathode, separator and electrolyte. Here cathode is sulfur, and the working mechanism of lithium sulfur battery is redox reaction mechanism. That is, a series of products are forming and the product formation is giving the capacity to the system. The advantage of lithium sulfur batteries, it can store more energy. So it have 10 times higher energy density compared to the lithium ion battery. Also, it have high driving range, that is around greater than 400 kilometer. It can travel in electric vehicles in a single charge. Also, the cost of lithium sulfur battery is also very low compared to lithium ion battery. So this is the method I used for preparing the carbon matrix for the lithium sulfur battery. I used banana peduncle and I prepared activated carbon as well as non-activated carbon. Activated carbon I used with the help of KOH. Later, I did the physicochemical analysis for confirming whether my material have all desired properties. First image shows the scanning electron microscopy images and it confirms the flake-like morphology. This morphology will help in accommodating more sulfur as well as diffusion of lithium ions. Later, I did the BET analysis for evaluating the surface area. From this physicochemical analysis, I found that it have flake-like morphology, it have high surface area and pore volume. Also, it is the pore size is in micro-mesoporous range. This all helps in trapping the polysulfates. So what is polysulfates means? As I already mentioned, a series of products are forming. These products are called polysulfates. We need to trap these polysulfates in the cathode itself for improving the performance of lithium sulfur battery. Later, we did the adsorption study by preparing polysulfate solution and mixing with the carbon. We observed that for the activated carbon samples, it adsorbed the polysulfate and the solution color changed to transparent. UV visible study also confirmed the same. Later, we did the electrochemical studies for evaluating the performance of the material in lithium sulfur battery, and we observed that for cyclic voltammetry as well as galvanostatic charge discharge studies, this activated carbon is giving better performance, good current response and high capacity. It indicates that if we are using our material as the cathode host in lithium sulfur battery, we can improve the performance as well as we can store more energy. Later we did the cycling studies as lower loading as well as higher loading, because higher loading is for checking the practical applicability of the cell. We observed that for cycling studies also our material is performing well. This all are because of the high porous structure, high surface area and some trace elements present in the material. Coming to the summary, I prepared the carbon source from banana peduncle by KOH activation. It have large surface area and pore volume. It helps in trapping the polysulfates and it is giving good performance. So this material is good for developing a cathode host for next generation energy storage applications. Thank you.